What's up, guys? In this video here, we're going to be taking a look at boiling water, which is some exciting stuff here, but we're going to talk about what actually happens when something boils. Now, for the most part, you probably are aware that there's one important thing that has to happen, and that's that you must heat something up. Okay, so for a liquid to boil, you want to heat it up. Now, so remember in our discussions of reviewing the solids, liquid, and the gas, liquids, they're not too far spaced apart. You know, they can flow past each other. There's a little bit, they have a bit more energy than solids would, and they can move around. Enough so that they can flow past each other. However, they can't quite make it into the gaseous phase because there is force between these particles keeping them together. Okay? So remember, in terms of liquid there's also gas particles, I'll just be in this purple here, that are pressing down on the liquid, preventing them from becoming a gas. Okay? These water molecules, they want to rise up into the gaseous phase so that they can be free and do whatever they really feel like. Okay? At the same time, there's restrictions there. Okay? There's the water particles on top that are pressing down, but also the gas in this room, which pushes down on the liquid, preventing it from becoming a gas, or water vapor in this case. Okay? So there's two things that have to happen for something to boil. For one, you have to add in heat. Okay? Remember, heat causes particles to move faster and faster. Okay? So as these particles begin to move faster, they can start to overcome some of the force that is restricting them. So all these molecules around here are going to be pulling them back and keeping them water. They want them to all stay together. But this particle here, say for example, wants to get out. It wants to break free and become and enter the gas phase. If you add energy to it, it begins to move around more. And if it moves more quickly, the other particles around have a harder time keeping it in place. And so as you're adding energy, they can overcome that intermolecular force and hopefully become a gas phase. Now, like I said, there's also these gas particles at the top pushing down, preventing this from happening. So not only do they have to overcome the force of these other water molecules around it, but they also have to be stronger than these gas molecules pushing back down. Okay? So as you have here, we've got a little hot plate. It's heating up the water, nothing all that incredibly exciting. We are trying to get this to boil. So the water molecules in here, they are being heated up, and it's starting to steam now. And so because of that, the water, they are gaining energy. Okay? And as they are gaining energy, they are able to overcome the intermolecular force between other water molecules in here. The air inside this room is also pushing down, preventing them from really escaping into that gaseous phase. Okay? So it's just starting to boil now. So let's take a look at what happens when we remove that energy source. Okay? As you would probably expect, it's going to stop boiling. Okay? So let's take a look at what is going to happen if I remove the energy source from there and we allow it to cool. Safety first, gotta get that on. Actually, I should probably turn it off first. That's probably the most important thing here. Okay, so we put this little seal on, and it popped off. That wasn't supposed to happen. All right, we're going to try that again. Just about to get boiling. Before we get there, just another quick point here about boiling. So again, for one, we have to have heat. The heat is going to add in energy to overcome the intermolecular force. The second thing that has to happen is that the pressure of the vapor must be greater or equal to the atmospheric pressure. Okay? So remember, the atmospheric pressure is the air all around us, which pushes down on different surfaces, including liquids. So in this case, what's preventing it from fully becoming a gas is the air pressure in the room, which is pushing down on the liquid, resisting them rising up. Okay? So for boiling point to be reached, we have to increase the temperature to the point where the vapor pressure is equal or greater than that of the atmospheric pressure. Okay? Once it's equal, it can push past the air that is pushing down on it and becoming gas as well. Okay, so a transfer of energy is happening here to get us to that point. Okay? So all right, we're going to try that again. Just about to get boiling. Before we get there, just another quick point here about boiling. So again, for one, we have to have heat. The heat is going to add in energy to overcome the intermolecular force. The second thing that has to happen is that the pressure of the vapor must be greater or equal to the atmospheric pressure. Okay? So remember, the atmospheric pressure is the air all around us, which pushes down on different surfaces, including liquids. So in this case, what's preventing it from fully becoming a gas is the air pressure in the room, which is pushing down on the liquid, resisting them rising up. Okay? So for boiling point to be reached, we have to increase the temperature to the point where the vapor pressure is equal or greater than that of the atmospheric pressure. Okay? Once it's equal, it can push past the air that is pushing down on it and becoming gas as well. Okay? So a transfer of energy is happening here to get us to that point. Okay? So all right, so our water is back boiling again. So now we can make our second attempt at this. So again, now that we've reached boiling point, we've added enough heat into the liquid particles, the water in this case, that the vapor pressure is now equal to that of the air around. And so now, as we add heat, pressure goes up. Because of that, they can join the air in the gaseous phase. Okay? So let's take this again. Two things that have to happen: energy and the vapor pressure has to be equal. Now, obviously, you guys know that adding in heat is going to make something boil. But now that we've reached our point here, what if I told you that there was another way and that I could actually boil it with some ice? This bag contains ice. It's a little bit hard to see. But I'm going to boil this liquid here with some ice. Hopefully we can get it showing up nicely for this video, and hopefully it doesn't pop off the second time. Okay, so that. And I'm applying some ice to the top here. And what you should see is there are bubbles forming again as I put the ice all around. So what is going on there? I'm just adding ice to the very top of the beak of the flask here, and this is enough to make the water boil again, even though I've removed it from the heat source. So what exactly is going on there? So what you guys are going to do, this obviously is going to be involving a bit of an energy transfer. So for you guys, what you're going to do from class now is take a moment, and I've posted a little Teams assignment there, and you are going to give me your best guess, your best hypothesis as to why I was able to reboil that liquid with ice. And normally speaking, you have to add in heat to make a liquid boil. In this case, I added ice to make our water boil. Okay? So remember, a hypothesis is your best guess. Based upon what you know and the information that you have learned in this class, you should be able to take make some sort of guess as to why this is happening. Okay? It's okay if you get it wrong. It's totally fine if you do that. Okay? The other thing I'm going to get you to try and do is, since it happened by accident, let's just see if you can figure out why the lid had popped off the first time I had made this attempt. Okay? So obviously at the first time I flipped it over. I was going to use this ring stand here to help just hold it so I didn't have to hold it with something hot. But then the lid popped off. Okay? They are actually related, but while you have some time now, take a few moments, and again, let's formulate a hypothesis as to why this happened. Again, if you're wrong, totally fine. I am just looking here for your thinking now and see what kind of information you're pulling out from our class discussions as to why this may have happened. Okay. Next class we have together, we will go over this and talk about it. So It'll be interesting to see what you guys come up with. Good luck.